in case you've missed it, proteins are really hot right now.
AI has turned biology upside down.
Really revolutionizing medicine today. New modalities that are changing the way we treat disease.
Changing how we think about protein design in a very day-to-day practical sense.
Imagine the protein walks in the door, you have its structure, you don't know what the function is.
You need efficacy, you need safety, and you should also probably consider convenience and today also scalability. A lot of different things to optimize for at one time.
None of this is possible without data.
It's one thing to have an AI engine and we all have the technology.
Machines can't learn from nothing.
You actually have to have a ton of data.
And so data is queen.
Data is queen.
Data is
Right?
queen.
There's no substitute for data in validating a model.
This is the key point. It is those large data sets plus AI means you can ask bigger and better questions in biology.
If you don't have the right kind of data and you don't prepare it in the right way, then you can't really be very successful.
And what Ginkgo is committed to doing is getting together as much data as possible around the industry and making it available to you.
You will have seen our foundries that are full of all of this really cool robotics hardware.
Common infrastructure and approach to library design, to high throughput screening.
High throughput lab automation and AI.
Physical experimental data is fundamentally important.
Integrated data analytics and model building.
One of the beauties of having a foundry at Ginkgo is we can actually start very wide and do a lot of experimentation and then zero in.
I just wanted to walk you through a schematic of what a typical Ginkgo experiment looks like for us in CAR T. So for us, one experiment is 720,000 unique tests.
This is a set of genomic data we have.
We've done a lot of testing of a lot of enzymes in a lot of functional space.
We have 2 billion in our proprietary data set from all these acquisitions we've done. All available, right, to you as a service if you want to train, your models.
Because we need AI to help design the experiments in a way so that we get the maximum information and value out of the experiments that we conduct so that we can feed those data back into the model.
As people developing products in synthetic biology, you should not need to be the world's experts in laboratory automation.
As we are iteratively engineering enzymes, taking predictions from models and testing them in the lab, we not only improve the function of the enzymes, but we improve the function of the models.
These are things that Ginkgo can be expert in, and you can just access the latest technologies.
What happens next? What do we do with all this new data, and what kind of questions can we ask now that we weren't able to ask before?